For decades, the very mention of the Bermuda Triangle has conjured images of inexplicable vanishings and spectral forces. This loosely defined region of the Atlantic Ocean, stretching between Miami, Bermuda, and San Juan, Puerto Rico, is supposedly a place where ships and planes disappear without a trace. Yet, official agencies like the U.S. Navy do not even recognize it as an existing geographical area. We've all heard the tales of ships swallowed by rogue waves or aircraft lost to strange magnetic fields. But what if the true explanations were both more mundane and, in their own way, far more powerful? We will explore the leading scientific theories, confront the enduring myth, and in just a few minutes you will understand why this notorious triangle holds such a peculiar grip on our collective imagination. Before we delve into the supposed mysteries, let's clarify what we are actually discussing. The Bermuda Triangle, for all its fame, lacks any official recognition from geographical authorities such as the U.S. Board of Geographic Names. It remains merely an arbitrary area within the western North Atlantic Ocean. The boundaries are, quite literally, made up by storytellers over time, which gives it a rather fluid definition. Historically, the area itself is one of the busiest shipping lanes in the world, connecting major ports. It is also, rather inconveniently for the mystique, one of the most hurricane-prone regions of the Atlantic Ocean. So, perhaps a certain level of maritime incident is not entirely unexpected in such a location. It seems the most enduring mystery might be why we insist on drawing an invisible triangle on a perfectly ordinary stretch of water in the first place. The ocean, it turns out, can be quite a dangerous place without any supernatural assistance whatsoever. Nevertheless, the stories persist, demanding more exotic explanations for what is often just challenging weather or human error. One prominent theory attributes the vanishings to what some call burps of death, explosive releases of methane gas from the ocean floor. Scientists have indeed found vast quantities of methane hydrates, essentially frozen natural gas, trapped beneath the northern Siberian tundra and deep within the world's oceans. These hydrates contain twice as much carbon as all known coal, oil, and conventional natural gas deposits combined. The theory suggests that if these methane hydrates destabilize, perhaps due to seismic activity, they could release massive bubbles of gas. When these bubbles surge to the surface, they might drastically reduce the water's density in a localized area. A ship passing over such a spot would suddenly lose buoyancy and sink rapidly, as if it had hit a patch of thin air. Russian scientists, reporting in Nature, linked similar explosive gas releases to enormous sinkholes on land, bolstering the idea that such powerful geological events can occur. This sounds quite dramatic. A genuine peril bubbling up from the abyssal plains. But that's not even the best part. The most interesting debunking of this theory is still ahead. But that's not even the best part. The most interesting debunking of this theory is still ahead, challenging what you might assume about bubbles and boats. While the methane hydrate theory has a compelling, almost cinematic quality, it faces a significant hurdle when confronted with basic physics. Bubble physicist Helen Chersky has publicly debunked the notion that methane bubbles could realistically sink a ship in the manner often imagined. For a massive methane bubble to truly reduce a ship's buoyancy, it would need to displace an enormous volume of water instantly. However, gas bubbles behave differently in water than a solid object. As methane gas rises from the seafloor, it disperses rather than remaining as one colossal, ship-swallowing bubble. By the time any significant amount of gas reaches the surface, it would have spread out considerably. The density reduction would be far too localized and temporary to affect a large vessel catastrophically, certainly not enough to make it vanish without a trace. A ship would simply pass through a slightly frothy patch of water. The ocean is incredibly vast, and events like these would be extremely rare, let alone precise enough to repeatedly target ships in a specific triangle. So, while methane hydrates are fascinating geological phenomena, their role in the Bermuda Triangle remains firmly in the realm of speculative fiction. It seems the universe prefers its mysteries to be a bit less convenient for compelling narratives. Beyond the dramatic methane scenarios, other natural phenomena have been proposed to explain the Bermuda Triangle's reputation. One persistent theory involves magnetic anomalies. The Bermuda Triangle supposedly lies on the 80-degree meridian, a unique line where the Earth's magnetic north and true geographic north poles are in perfect alignment. This alignment could, theoretically, cause compasses to malfunction, leading to navigation errors and ships or planes going off course. However, magnetic anomalies exist all over the planet, and pilots and mariners are trained to account for magnetic declination. A slightly off-kilter compass is unlikely to explain a complete disappearance. More prosaically, the area is simply very active. In the days before advanced radio and radar, ships and planes were lost at sea with alarming regularity everywhere. It was, as they say, one of the perils of the job. Add to this a predisposition for hurricanes, and you have a recipe for severe weather. These natural, unglamorous explanations tend to be overlooked for something far more sensational. But as we'll see, the most compelling reason for the myth's endurance lies deeper than any single event. Beyond all these specific theories, there's a simple, overarching reason this myth endures, revealing more about us than about the sea. Ultimately, the mystery of the Bermuda Triangle is less about unexplained phenomena and more about the enduring power of a compelling narrative. Statistically, the Bermuda Triangle is no deadlier than any other busy stretch of ocean. The U.S. Coast Guard, for example, finds no evidence that mysterious disappearances occur with any greater frequency there than anywhere else. The real mystery is our human tendency to create patterns and explanations where none exist, especially when faced with the inherent dangers of the natural world. The vast indifferent ocean with its storms, currents, and navigational challenges has always been a place of both wonder and peril. When a vessel vanished in the era of primitive communication, it simply vanished. It was a tragic, but not uncommon, occurrence. The myth of the Bermuda Triangle allows us to attach a reason, however fantastical, to the unknown. It transforms routine, albeit tragic, incidents into something grander, something that tickles our primal fear of the unexplained. It reminds us that sometimes the most profound mysteries are not what the world hides from us, but what we choose to believe about it. We crave the extraordinary, even when the ordinary is plenty complex and powerful enough. So, the next time you hear about the Bermuda Triangle, you'll know that the true story is perhaps even more intriguing than the myth. It's a tale of geological forces, human ingenuity, and our fascinating predisposition to seek out the extraordinary. The ocean is vast and unforgiving, offering plenty of real dangers without needing a special triangle-shaped anomaly. What remains is a testament to the human imagination, our desire for mysteries, and the simple truth that sometimes a ship or plane gets lost at sea. It's a powerful reminder that the real world, in its complexity, offers enough wonder and challenge to satisfy even the most adventurous spirit. Perhaps the biggest mystery is why we still cling to these tales. Go ahead, challenge a friend with these facts.